Hello, and welcome to this fourth video in a series on hydrocarbons. This one deals basically with different types of formula. Now you should already be aware of what the term hydrocarbon means. A hydrocarbon is a compound that contains only hydrogen and carbon. Now there's a whole bunch of families of hydrocarbons, one of which is the alkanes. Now the alkanes are saturated. That means a molecule of an alkane contains only single bonds. The general formula for alkanes is CnH2n plus 2. So, in a molecule of an alkane, however many carbon atoms there are, there'll be twice as many hydrogens plus 2. You should also be aware of the alkenes. Now, alkene molecules are unsaturated. They contain a carbon-to-carbon double bond. Their general formula is CnH2n. In an alkene, however many carbons there are, there'll be twice as many hydrogen atoms. And finally, we looked at the cycloalkanes. Now, in a cycloalkane, the carbon atoms are arranged in a ring. These molecules are saturated. They contain only single bonds, but the general formula is CnH2n, the same as for the alkenes. Now, I've used the term families of hydrocarbons rather loosely. What I'm really talking about here are called homologous series. Now, a homologous series is a group of compounds which all follow the same general formula, and they carry out the same chemical reactions. And all those families of hydrocarbons we've looked at, they are all homologous series. Now notice, alkenes and cycloalkanes, they do have the same general formula, but they do different reactions. That's why they're not the same homologous series. They may have the same formula, but different reactions. We'll look at that later. For the moment, I want to introduce structural formulas. Consider pentane, C5H12. Notice, fits the general formula for alkanes. Double the number of carbons, add 2. That's its molecular formula. It tells you which atoms are in a molecule. So that's its molecular formula. But all it tells you is which atoms you've got, not how they're joined together. Compare that with this. That shows you which atoms you've got, but shows you which atoms are joined to which and how they're joined. In this case, all by single covalent bonds. This is a full structural formula. Now, it can get a bit wearing, writing down lots and lots of C's and lots of H's, so sometimes we simplify this. Consider just that highlighted group of atoms there, at the end. If we were just writing the formula for that, we'd write that as CH3. Now we can move on to the next carbon. If we were just writing the formula for that bit, that would be CH2. And we can keep going along the molecule. You've got another CH2 there, and another CH2 there. And then finally at the end, you've got a carbon and 3 hydrogens, so that would be CH3. That then is your full structural formula for pentane, and now your shortened structural formula. Notice the difference. In the shortened structural formula, it still tells you which atoms are bonded to which, but doesn't show you the bonds themselves. Okay, let's move on to alkenes. Okay, first of all, I'm going to start with an alkane, so that we can compare the two. We're going to start with butane. 4 carbons, 10 hydrogens. And there's the shortened structural formula of butane. Now notice we're starting with alkenes for the moment. But if you remember, when we introduced alkenes, we did it by throwing 2 hydrogens away. So let's do that. Now, to ensure that both those carbons have 4 bonds, we'll swap that for a double bond there, look. So that then is now no longer butane, but butene. But see what effect that has on the shortened structural formula. You've lost a hydrogen each from the first two carbons. So that CH3CH2 becomes CH2CH. That then is your shortened structural formula of butene. You can, if you want, put the double bond in just to show where it is. Though the more used you get to these shortened structural formulas, the less necessary you'll find that. Notice, by the way, the double bond doesn't have to be at the beginning. Suppose we'd started with butane and thrown those two hydrogens away. That means you need the double bond in the middle of the molecule. Now the shortened structural formula for that has two CH's in the middle and two CH3's at each end. If you want to put the double bond in, it looks like that. Okay, finally the cycloalkanes. In this, remember, the carbon atoms are arranged in a ring. So that then is cyclopropane. Now honestly, there's not a lot you can do to shorten that. All you can really do is turn the CH2s with bonds into CH2s like that and like that. Notice the last one though. Look, I've written this as H2C because the bonds in the ring have to attach to the carbon atoms. If it had written CH2 there, it might not have been obvious that the bonds ran from carbon to carbon. So I've reversed that to H2C. It means exactly the same thing. Okay, so where should we now be? You should be absolutely clear now what the term homologous series means. It means compounds with the same general formula and the same chemical reactions. You should understand what the term general formula means and apply it to alkanes and alkenes and cycloalkanes. Using a general formula allows you to work out a molecular formula. Each alkane, for example, has a different molecular formula, but the same general formula. A molecular formula tells you which atoms you've got in a molecule, but that's all. You should also know how to write shortened structural formulas. The shortened structural formula gives you extra information. It tells you which atoms are bonded to which. The full structural formula takes you a stage further to actually show you the bonds. Right, that's all for now. Thanks for watching. Hope to see you again. Bye just now.